Hi, good morning, good afternoon, and good evening. Thanks for joining today at the HPC and AWS event. My name is Jeff Critton. I'm an account executive here at Rescale, and I'm going to talk a little bit about what Rescale does for HPC and how it can help you achieve your time to market goals. And with me today is Riaz.
Hey everyone, my name is Riaz Diakad. I work as a solutions architect at Rescale. I started my career as a chip design engineer, so I'm very interested in working with customers in the semiconductor space and help them transition to cloud.
Thanks, Riaz. So if you haven't heard of Rescale, let me give you a little bit of background. So Rescale has been around for about 10 years. We were founded in 2011. We're the #1 high-performance computing cloud platform in the marketplace. Our customers range from small startups all the way to Fortune 500 customers. We're still independent, and we have 80 million plus in Silicon Valley venture capital at our disposal. We're the leader in the space with over 600 deployed HPC applications. And so why is that important to you? When you log into our platform to get going on the cloud, you'll see all the apps that you use every day ready to go. So you don't have to spend time installing applications, testing applications. All you need to do is log in and get your work done. Our enterprise customers are all some of the big logos that you're familiar with. And in the semiconductor industry, if you look at our ecosystem, we're partnered obviously with AWS as we're here today. Samsung, TSMC, and Global Foundries are our foundry partners. On the software side, we mentioned here Ansys, Cadence, Synopsys, Mentor, and there are a couple others that aren't listed here as well. You'll find us headquartered in San Francisco, and we have offices around the world as listed there. We have a number of investors, as you can see by the photos there, and we serve at various marketplaces. When we were founded, we focused a lot on CFD simulations for aerospace, as opposed to companies like Boeing using wind tunnels to optimize the design of their airplanes. They would use simulation to do that instead. It would save them months of time to market on the particular types of simulations. We also serve the automotive market, the semiconductor market, life sciences, oil and gas, financials, public sector, and various industries. You can read about us at the various analyst endorsements. McKinsey, Gartner, Goldman Sachs, IDC all have reports on us. So why semiconductor to the cloud and why now? Well, semiconductor seems to have been a little bit late in adopting the cloud pervasively across the industry. And if you look at the reasons why, the complexity there is probably higher than anything else. It's not as simple as a CRM system, for example. You just don't go to one software vendor. You're working with multiple software vendors. You're working with multiple fabs, each of which have intellectual property that needs to be identified and put securely on the cloud. So you have to bring a whole ecosystem to deliver in order to be successful. Security for years has been a question mark in the cloud, but I think that's well past us now. We're being endorsed by the top 3 fabs of the world, representing 80% of the global capacity. And what's really the driving factor? Well, today, if you look at semiconductor design flows, folks going to 10, 7, 5 nanometers, they really need high performance computing in a massive scale way, because doing things like timing sign off for full chip or IR analysis, even if you throw a couple hundred cores at it, will take 5, 6, 7 days. So you really need to start thinking in the thousands of cores. And even mid and large companies typically don't have that type of capacity free in their data center to get that job running immediately. So it's all about time to market. And those sign-off flows, if you have errors at the first output, you can go back and have to wait another week, go back, wait another week. So without the cloud and getting that done in 3 or 4 hours, you can really impact your time to market and your schedule. And you really want to keep on track with respect to that. So the cloud is there now, and it can help you get time to market. So we're focused in on our fabless semiconductor customers, and what we offer them is a turnkey solution. So when you log into the system I mentioned, you're going to see software from Synopsys, Cadence, Mentor, and other EDA providers. All you're going to need to do is upload your data design base, and then essentially a script to run that software, and you're off to the races. Our security is industry best in class. We've been approved by all the major fabs, so you don't have to worry about hosting your fab data in our cloud. We give you all sorts of ability to control. So for example, you don't want somebody using the infinite compute in an infinite way, or you'll have an infinite bill. And so we have abilities to manage the budget, administer that budget productively, assign particular software and hardware together to your engineers. And what you get offered really is agility. So you really want to get that tape out done on schedule or even early. And using cloud, you can put enough compute on the table to make that happen. Using unlimited, you can run unlimited workloads on things like AWS infra. So what parts of the design flow are really well optimized to go to the cloud? Well, if you break it down into 2 chunks, sort of the front end versus the back end, At the front end, typically people will have millions of small files, well, maybe not millions, but a lot. And you really need to understand your whole infrastructure on-prem to be able to migrate that complexity to the cloud. So if you're going to do things like Verilog simulation in the cloud and you have a large database and thousands of small files, you're really going to take a lot of time to figure out how to migrate over that to the cloud. So if you really have a data center that's under pressure, I would focus more a little bit on the back-end design flow. It's a big file that goes in, right? If you're going to do static timing analysis, for example, and a big file that comes out. So the simplicity of getting that up and running is very easy and quick. All you have to do is transfer your data design base. And it's really well suited today, especially at advanced nodes for static timing analysis. DRC LVS is another one, place and route, IR analysis with tools from companies like Cadence and Ansys. So back-end design, probably a little easier to get started. Front-end design, obviously you're running so many simulations, it's useful, but a little more complex on that side. So some examples of the ecosystem. We partnered with Samsung, and we are the sole provider to their cloud design platform under the Samsung Advanced Foundry ecosystem. So it's called SAFE-CDP. What that means is Samsung customers that want to go to the cloud are going to be using Rescale as a platform, and Samsung will have their intellectual property up and ready to go for their customers. What have we seen there? Well, we've seen a 30% increase in efficiency from getting to market on the physical implementation for a company called Guyon Chips. They did a 14 nanometer automotive design. And why don't we listen to them talk about their experience?
SAFE CDP by Samsung Foundry and Rescale is an exciting new paradigm for the semiconductor industry.
SAFE CDP is a key strategy in making Guyon chips highly competitive. Guyon in Korean means the center of the world. Established in 2012, Guyon chips continuously works to be technologically competitive in the fab industry. Guyon chips strives to implement the best technology and test new design paradigms to satisfy customers, especially in semiconductor chip design for both front-end and back-end.
By collaborating with Rescale, a leading company in high-performance computing, we wanted to find a way to give fabless customers direct access to all the benefits of working in the cloud.
Some might wonder how much hardware is needed to create a small chip. The process of designing and verifying semiconductor chips is extremely complicated. Semiconductor chips require many different EDA tools with unique computer specifications based on their types, and obtaining new hardware each time is realistically impossible. Using a computer without optimal specifications takes a very long time, and projects usually have tight deadlines and require a great amount of engineering resources to complete them on time. Our engineers' time is a great company asset, so if we can save their time and give them more time for research, we can make the company more competitive in the market.
One of the advantages of using SAFE CDP is being able to save time. An engineer knows which computing hardware is best suited for a given project. By using optimized hardware and reducing design and verification times, we have more time to focus on research, which undoubtedly leads to a better outcome.
From the engineer's perspective, we can focus solely on the design process. By simply logging in, we access a convenient environment for designing. Previously, we commonly found that there was no way to predict the result's final data size, which created stress for the engineers. Since we can now easily secure a scalable storage space needed for any size results, we don't have to worry anymore and can focus on the design process.
Another advantage of how SAFE CDP improves competitiveness is its ability to provide a collaborative environment. The process of obtaining and managing foundry design kits and process scripts is complex. Using SAFE CDP, foundry design kits can easily be obtained and instantly applied to the design process.
Communication between engineers is also easy. Normally, with many engineers working on a single project, file handover in each process is inconvenient. SAFE CDP allows engineers to be able to communicate and share results, despite being physically located in a different region or abroad.
The bottom line is, customers are able to simply select the best tools and hardware needed to accomplish their goals.
Guyon Chips supports its customers by continuously growing and innovating. We are pleased to have SAFE CDP as the driving force behind achieving our goals.
기쁩니다.
So let's just summarize sort of some of the things we saw here. So they talked about productivity and how easy it was to use the platform. So the reason that is, if you look at this particular slide here, what we have is we have all the major EDA software providers on the top. They feed into our platform, into the software tile here. On the left, we have the Rescale technology, giving you the ease of use and everything you need so the applications run productively in the cloud. On the right-hand side, we talk a little bit about the ScaleX platform. And then at the bottom, we talk about Amazon's technology and how that helps us make the EDA apps run productively. So a great example is when you run EDA software, you really need an NFS type file system. So our platform will understand that this software requires a particular type of NFS storage system, and it will automatically allocate that storage during your runtime, so you don't have to be worried about those particular details. The screen you see is really a screenshot of the platform, and what you do when you run Rescale, as you'll see from Riaz, you just define your input, which is your data to run on, and then you pick the software you want to run the data on. You generally upload a script, and then you go. So within about 10 mouse clicks, if you've never used cloud before, you're literally up and running your applications and getting your work done. It's quite incredible. And the ecosystem is really important, and Rescale was very fast at creating a productive ecosystem. So if you look at our core EDA vendor partners, Cadence Vendor, Ansys, Keysight, and others, they provide tools into the platform. We have foundry support from TSMC, Samsung, and Global Foundries, which isn't listed on this slide. They provide access to their PDKs into the cloud. We work with a number of IP vendors, and you have to work with those sort of as one-of exceptions and call them and make sure that you're okay to put their IP in the cloud, but there should not be any issues. And from an infrastructure point of view, here we're talking about AWS. And so when you go to the cloud, you can take a few different approaches. You can come to a company like Rescale and get a commercial offering, sort of the best in class in the industry. Or some folks, some folks I've worked with, they started on the do-it-yourself approach. And you go down the do-it-yourself approach, you have a lot of work to get done. You have to, first of all, select who you're going to work with. And so once you select that partner, you have to negotiate agreements and pricing and everything else. Then you have to go ahead and look at different workflows. Every cloud provider has their own unique set of APIs and everything else, so you have to build workflows to make your jobs run. And then you want to make sure that your engineers or whoever is using the cloud have some amount of financial controls and constraints around there, so you can predict budgeting and not be surprised by a particular build. And once you build something, you obviously have constant maintenance because things, eventually there's always bugs in software, etc. So going through these 4 steps, if you're in a crisis and need to get some jobs done in the cloud, this is going to set you back probably months of time to get all this working. Or you can come to a commercial provider with a simple business model where we just add pennies per hour per core and be off to the races literally the same day that you're into the platform. Because we've already all done the negotiations with Amazon in this case. We preloaded all your workflows. We give you full control and insights into things like budgeting and access to the environment. We're always providing new core types and cloud providers and workflows up to the platform. So if a piece of software isn't there that you'd like to have there, we can generally get that done for you very quickly. From a control point of view, it's really important to be able to understand who's using the platform and how they're using the compute. So we have something called our Insights package, which gives you full visibility into projects at a given company. So in this particular example, we have Acme Electric. They have 4 projects being run in the cloud. Here's the software that they've been allowed to access. They have hardware filters such that they can only use this software with particular core types. You can see how many members are part of that workspace. You can see the different groups that they have and how many members per group. You can even assign budgeting at a group or individual level to make sure people don't surpass a particular threshold on the financial side. So it gives you full controls. There's a number of screens here that we could go through, but in the essence of time, we'll just focus on this one. You can dump all the data out to something like Excel if the pre-canned screens are not useful for you. And it gives you the ability not only to control the budget, but to see what's being spent real time, on a daily basis if you wanted to go in there and look, so there's no surprises from a budgeting point of view. Very important for larger organizations. In this case, I'll hand it off to Riaz for a demonstration.
Thanks, Jeff. That was fantastic. In the next 30 minutes or so, I want to talk about 2 important pieces. The first is the different architectural elements in our platform that helps you to run EDA workloads in a seamless manner. And in the second part, I'm going to walk you through a demo to understand how to set up a simple DRC use case and run it in a seamless fashion. So first, let's talk about the architecture. What is Rescale? Rescale is an intelligent control plane for running EDA workloads. Rescale is built on top of REST API. There are several ways customers connect to our platform. The most common way that we see is through a web-based UI, but you could also connect to our platform through a CLI application or even automate every step using REST APIs. So if we talk about running an EDA workloads, there are three important pieces of stack. The first is the application layer. On our platform, we have close to 600 plus applications. And specifically when it comes to EDA, we work with all the major vendors in this space, Cadence, Mentor, Keysight, and work with them closely to onboard their applications for running different types of front-end design, back-end design, physical verification, and so on. In addition to that, we also have a lot of tools which is used for doing machine learning and data analysis. For example, you could be running a huge regression job, and you might want to run an ML analysis on top of it to understand the yield output. That's entirely possible using our application stack today. The second piece, and where we add a lot of intelligence, is around infrastructure automation. The Rescale platform can intelligently distribute your jobs across different availability zones within a region, or even like different regions as well. So all this intelligence is built into our platform. And in addition to making sure that we can run your workload successfully, taking advantage of both spot and instant markets, we also do license management. So we can connect to your on-prem servers via an SSH or a VPN tunnel, or we could also host your licenses directly on the Rescale platform. When you run jobs through AWS, it takes advantage of all the networking in between. Like we could be using nodes which contain 10 Gbps Ethernet, or we also have nodes which support the EFA, Elastic Fiber Adapter. Security is one of the most important pieces in our platform, and it is the bedrock on which we build the platform. So we have like a multi-tiered security architecture where customers get to control different aspects. Like for example, you could set up multi-factor authentication, you could set up like single sign-on, and you could also set up like own security policies which is compliant with your InfoSec. And the last part is when customers are running workloads, it's important to also monitor how the jobs are running, where the jobs are getting launched into, how many users are using, which users are part of which group. All those are actually monitored on our platform and is easily available for the users to digest. The most important part about running EDA workloads, I would say, are three pieces. The first is storage. On our platform, we support both object-based storage as well as block storage. So like what this does is it helps you to run workloads by reading files directly from your object storage, or you could also spin up like an EBS volume with NFS mount and attach it to running jobs either in a persistent fashion or using it as scratch as well. The second part is when it comes to running the workload itself, I've seen like there are two major use cases. The first use case is customers tend to run certain workloads in a batch fashion. That's entirely possible today. But I've also seen customers sometimes want to run it through a visualization node, through a VDI attach. So here in this scenario, what we do is we can attach a VDI to the head node of your compute cluster. In this case, we actually use a nice TCV technology from AWS. So let's talk about the use case that we are going to be covering for today's demo. What I have in mind is a design rule checking and verification. If we talk to customers as to what are their most intensive workloads today in the EDA space, DRC definitely comes up. Meaning, I've seen customers who say that some of their DRC runs is very compute intensive and can take up to several weeks to complete. So this is where you want to take advantage of the infinite power of cloud and really parallelize it so that you can get down your simulation time from weeks to even hours. That's precisely what we are going to be talking about today. So if we actually look at this architecture and setup, I want to say that there are three main pieces to it. The first is before you launch a DRC run, so you want to set up your simulation environment. So this is where we use a feature called as high performance storage on our platform. So this high performance storage, it contains all your chip files, your layers file, your rules file, and whatever is necessary to run your DRC job. So once you have your input files available in your high performance storage, then what you could do is you could actually run DRC as a batch job. So now this application can really take advantage of multiple processors. It can also run across multiple nodes as well. So what we are going to do here is we are going to read all the input files, and then we are going to be running this across multiple nodes. And essentially by doing this, we are solving the key bottleneck here. Once you run a DRC, what you're doing is you're generating an ASCII file, which is basically telling you which layers parse the DRC, which regions fail, and so on, right? So that's actually the second step. The third step, what you want to do is after you're running your DRC, you might sometimes want to understand if a particular layer or a polygon failed, and that's what you're reading from your ASCII file. You'll want to correlate that to your layout to understand where exactly is the failure so that you can go and modify the layout. The beauty of Rescale is you can do all of this in a single platform and you don't have to go back between on-prem and cloud. So the third step, what we are going to be doing is we are going to be running DRC in an interactive fashion where we'll be using a couple of tools from Mentor, Design Rev plus RV, to essentially do like an interactive debug. So let's talk about the actual scenario that we are going to be using for our demo today. For this demo, I have 3 designs. The first design, design A, which I call it as, it's a very conservative design. So I'm not really pushing my limits on the different metal layers and the polygon layers. I know for sure that it's going to be compliant with DRC. So that's my first design. I get a little bit adventurous with the design 2 and design 3, where I have pushed a few layers beyond the actual design rule to meet performance specs, right? But while doing that, I also want to make sure that I did not violate DRC. That's essentially what I'm trying to do. So I want to run DRC analysis for all the 3 cases and then verify if these designs are passing DRC or if they are failing. And if they are failing, which are those layers I need to be concerned about? So let's dive into a demo. So I've logged into the Rescale platform, and this is where we are going to be doing the demonstration. So I have signed up into my account, and this is an EDA demo account on the Rescale platform. The 3 things that we are going to be seeing in this demo is first, how do you set up a storage device? This is essentially the high performance storage. How do you, what is the size of the device? How do you bring in your files? Those are the aspects that we are going to be covering. The second part, we are going to be running a Mentor caliber job in batch. And in the third part, we are also going to be running it interactively to do a live debugging. So let's start with the first portion, which is what is a storage device and how do I set up one? A storage device is essentially high performance storage where we use an EBS volume with NFS mount. So it is a shared storage. Now there are 2 use cases where customers can use it. The first is you might want to use high performance storage in a persistent fashion for storing your data. Or in the second case, you might want to use a high performance storage to essentially use it as a scratch device. So it's possible to use it for both. So today we are going to be talking about the latter, where we are going to be hosting all our input files in a storage device, and then we are going to be using it as a scratch. So how do I set up a storage device? It's very easy to set up on the Rescale platform. And a quick note is everything that I'm doing through the UI can all be automated through the API. So essentially you can have like a single job submission script, which will start a storage device, upload the files, run the job for you, and even download it, right? So it can all be automated. But it's helpful to understand how to set it up through the UI so that you get all the details. So if I want to set up a storage device, I can give this a name. So I'm just going to call it demo HPS. Right? The first important piece about storage is deciding how big you want to have the device. So here, let's assume for the sake of this discussion, I just want like a 500 GB storage device. We also have the auto extend feature. What it does is it automatically scales the storage device when it hits a particular disk space, and this is also configurable. I could have a policy such that I want my storage device to increase when it hits 90% disk space, or I could also change it to something like 50%, right? It's entirely up to how you want to determine the policy. Now, in order for us to start this storage device, we can choose what type of VM that we are running on top of EBS. So essentially, we have a couple of options. So you have like a low-cost offering using C4, or if you need a little more memory and more IOPS, you can also use the R4 machine. So let's just use the first option. We can use R4. And if you're not running heavy compute on the storage device itself, I would recommend that you can just use like 1 to 2 cores. And you don't need to worry about the regions and where you're launching into. So by default, we launch into US East 1. But as a user, you can also configure it. And there are other pieces around notifications where you have like more granular control on how often you want to get notified. You could set up different types of policies saying that send me a notification every day, every week. It's all like entirely configurable, right? So once you do all these things, all you have to do is launch this job. So it essentially takes like 3 to 5 minutes for the storage device to spin up. In this demonstration, I've already have a storage device which is up and running, and that is what I'm going to be using. So if we look at this storage device, so once the storage device is up and running, we can obviously browse the files through the UI. So you can actually come to the file section. You can see like, I have like several folders, and each of those have their own set of rules file and chip files. You can also create your own folder as well. The beauty is like you can also SSH into the storage device either to an in-browser SSH session, or if you can also do it from your terminal as well. Like for example, I could SSH from my in-browser terminal here, and then I can do an ls. I can see if I go to my work folder, so I should see all my files here, right? All my folders. So let's actually do it through the UI today. So let's go ahead and create a folder. And once we have a folder, we are going to be uploading files to it. So let me go ahead and add a folder. I'm going to be calling it as demo1. So we created this folder called as demo1, and now we can add files into this folder. If I have files on my cloud storage, which is essentially my personal S3 bucket, I can upload it from there. Or I could also upload it from my computer as well. So what I could do is I could go to my desktop, and then here my files are living under this folder. So I could essentially be like, I want all these 3 files, right? And what are these 3 files? This is my rules file, this is my OSS file, and this is my layering profile. All the 3 that you need to run a Mentor Caliber job. You can see that the files are getting uploaded, and once they are uploaded, they should all show up here. So this is actually the first part. So what have we done so far? So we created a storage device and we uploaded our input files, so which is essentially needed to start running DRC. Now let's move on to the second part, where we are going to be launching Mentor Caliber DRC in batch using these files. And We'll also walk through all the different options you have at your disposal. In order to launch a batch job, all you can do is click on create new job. So here I want to pause and talk about running a batch job itself. It's a very straightforward process, and the framework is pretty much here. So you have your input file, which you can add from your cloud storage or upload directly from your computer. If you have any storage device running, you could also mount it from there as well. The next step is choosing the software. So this is where you decide what type of application that you want to run, right? You could run a job using like a Cadence application, using a Mentor application. You have flexibility to pick and choose what software that you want to run. In this case, I'll be focusing on Mentor Caliber DRC. The last part is really choosing the hardware. This is where you decide on what hardware that you want to use. It could be like a general purpose compute, something like a C5 or C4 type machine. It could be a high memory node. Some workloads would require high clock speed. So on our Rescale platform, we have close to 52 different types of architecture to really give you flexibility to pick and choose any type of hardware suitable for your workload. So let's give this job a name. I'm going to keep it very simple. The demo batch job, and then I am going to be using files from my storage device. So I'm going to say attach from my storage device, and then I have this storage device which is already running. So let's go there, and then I am going to symlink these 3 files. So you can see that now we have linked the 3 files necessary to run the job. Let's move to the next step. So here on our platform, you can see that we already have a lot of applications from different vendors suitable for EDA. On our platform, we continuously keep updating these applications as well as onboard new applications. If you have your own custom application, we could also onboard that and make it available as a private version. So we really have a lot of flexibility to let you bring any type of application to our platform. So here, let's go ahead and choose Mentor Caliber DRC. So once we choose the application, you can then pick the version of interest. On our platform, when we onboard a version of the software, we don't really duplicate it. So that gives a designer a lot of flexibility to go back and run using an old version. This I've seen being very useful in the EDA industry. Especially I've seen customers use a particular version of the software for like a year or a couple of years for the entire life cycle of their project. So you can always choose whatever application is required for your project. So in this, for today's demonstration, I'm going to be using the 2019 version. So I choose that. You can also see that once you choose an application, we automatically create the command line for you. So all we need to do here is just add the rule file, right? So we need to add the rule file. So let's actually copy this. And if you also want to write all these to a log, you can also do like a drc.log. So this should take care of running our application across like multiple threads as well as multiple cores. All this is automated in the background for you. In terms of running the application in the EDA space or the semiconductor, it's mostly bring your own license. However, if certain applications support on-demand licensing, we can do that as well. If it is bring your own license, so we can either connect to your on-prem license server through an SSH or a VPN tunnel, or we could also host the license for you on our infrastructure. So today for this demonstration, I'm going to be using licenses hosted on our infrastructure on T2 micro instances and use it for running. So this is where my license server is residing. And if I do a check availability, it also shows all the licenses that is available at my disposal. And if some users are running, which is not the case today, you can also see those as well. So let's recap. What did we do here? So we attach our input files, mounted it directly from our storage device. We chose the software application. The next step and the most exciting step is choosing the hardware. So on our platform, we have like different types of hardware configurations suitable for a variety of workloads. So we have like general purpose code types, which are the C series machines. We also have the high memory offerings, essentially the M5, the R4, all these are available. We also have the Z1D, which is a high clock speed version, which could be useful for like certain EDA workloads. And if some require like high disk, those are available as well. The beauty is when you choose any of these code types, let's say for the sake of demonstration, let's choose a C5 general purpose instance today. So when you choose the hardware, we also tell you what is the underlying infrastructure, what is the clock speed, how many cores are available per node, what is the overall memory of the head node, what is the memory per core. All these information help you really to decide the most optimal hardware to run your workload in a cost performant manner. And at Rescale, we are also building intelligence into the platform where we, at some point, will automatically start recommending what code types would be available, would be helpful for a workload, right? So let's go ahead and go with the C5. When you want to run the hardware, you can also decide to run it either using the spot market, or you can also run it using the instant market. So on our platform, we have options called as on-demand pro, which is essentially instant, and on-demand, which is taking advantage of spot market. So you can pick and choose like how you want to run your workload as well. And the beauty of scale of cloud something is you can really scale to as many number of nodes, as many nodes and cores as you want. For today's example, this is a very small example. So what I'm going to do is I'm going to stick with 8 cores. And wall time, you can think of this as a safety flag. So essentially, you can say that if you set a wall time of 48 hours, so it's going to be a hard kill for the cluster, right? So if the cluster hits 48 hours, it's going to get terminated no matter what. So this is really helpful in scenarios like, let's say that you have a colleague who submitted a job on a Friday and then went on a week vacation, right? Now, for some reason, the application is just hanging there. And if he did not set an appropriate wall time, the cluster just would keep running infinitely and waste resources. In order to avoid scenarios like that, we built guardrails and safety nets into the platform such as wall time. The post-processing is really optional. It depends on the workload. More if you have like a Python script or like a MATLAB to look at the data and do post-processing, you can certainly attach it here. If not, you could just skip this step. And we are ready to submit. So we have our input files, which is mounted via the HPS. So we have our software and hardware. And now we can save this job. When you save a job, each job will have a unique ID. And this is how we try to capture the intelligence around the job. So we use all this metadata information to surface analytics such as, which user was running a job, how long did they take to run a job, how much did it cost. All this information is available for an administrator of the account. So I submitted this job. And essentially, when you submit this job, what happens is it goes through like multiple cycles. The first step is precondition, where we run a bunch of precondition checks. We make sure that the user has budget, has license, has the correct command line to launch a job. So if one of these preconditions fail, then there's no point in starting a cluster. So we'd actually terminate the job. But in here, like all our preconditions pass. And now we moved on to the stage where we are starting the cluster. So this is where like we are going to spin up a VM, attach the EBS volume with the software. And then once the software is launched, then we are going to run the application. And once the application is completed, we're automatically going to tear down the cluster and move the files back to your S3. Now you can imagine doing something like by yourself directly on the cloud, but it's always tedious. You need to configure a lot of things with respect to VPC, security group, migrating data from EC2 to S3 and back and forth. So all those things are automated for you. And all you have to do is just click 3 buttons to start running this on AWS. While this job is running, I actually want to share a couple of useful tips when you are running batch jobs. The first is when a job is running, you could also say that, let's say that this job is going to start now, and you might have scenarios like where you want to talk to our support team to get ask for like either guidance or to troubleshoot an error. So you can certainly share this job with our support team. So it's only when you do that we have access to your input file. Otherwise, all the data that you have on your platform is encrypted and is available only for the user. No one has access to your data. All right. So far, we have seen how to set up a high performance storage device. We have seen how to run a batch job. And the last part of this demo is after you run a DRC job, how do you actually do a post-processing, right? Like how do you open it interactively and verify your layout against your DRC output and understand like, which layers needs to be modified. So let's talk about that. So in order to launch an interactive job, the framework is exactly the same. So instead of using the job type as basic, you would use end-to-end desktop. And then once you use end-to-end desktop, you can attach your input from your storage device. So you can also again choose your software of interest. You could set it up as Calibre DRC Interactive. You can choose your version of interest. And here, like, you can have the same type of license settings. And that's pretty much it, right? So once you do all these different pieces, so what will happen is this job will start. And once the job started, so you'll get this option that you're currently seeing, connect interactive session is grayed out. So that option will be available for you. When you click on that, we are essentially attaching a VDI to your head node. And this VDI is running on nice TCP technology, right? So using this, we are actually setting up a visualization where you can go and you open your application. Let's actually take a look at this case. So I already have a batch, have an interactive job that is running. So you can see that in this job, I've attached a storage device where I'm going to be using all the files from my storage, EDA storage. I have my application and my hardware. And now if I want to connect and open this application interactively, all I have to do is say connect interactive session. So when you do that, so here you can see that we are using the nice TCP technology, which is one of the best in class. Now our customers have given great feedback. So it has like very low latency and is really useful for doing complex post-processing and GUI rendering. So here, like I'm inside this VDI, and now I can say, open my terminal. So let's say I have my terminal, and then if I go look at inside my storage device, so you can see that all the different folders that existed, demo 1 is the one which we launched and is currently running. But for this demonstration, let's actually go inside test case 1 and see what files we have. So here we can see that we have the input files. You also have the RDB, which is the ASCII output from Calibre. So we have the results as well. So we could essentially take this case and then open it interactively, right? So in order to open the Calibre interactively, what you can do is you can enter the command Calibre DRV. So once you do that, it's essentially going to open design drive, And once design rev is open, from there you can also open RV interactively. For the sake of demonstration and making it easy, I have already have a session of design rev which is running, right? So, okay, so this portion, like let's redo it here. So for this sake of demonstration, so you can see that we already have a session of design rev running, and it contains my chip design file. And now if I want to understand like where I need to make modifications in this layout, I have to open design, open RV. In order for me to do that, I can click on verification and I can say start RV, right? But I already have a session of RV running, so let's just use that. So you can see that we have both design rev and RV running, and now this shows us like which are the layers have which are passing DRC and which are the ones which are failing DRC. Let's actually go down this list to understand that which one needs some attention. You can definitely see that metal one needs a lot of attention. So there is a lot of pieces that are failing DRC. Now what I can do is if I actually click on one of these polygons, so I get information around which are the coordinates, which is failing. But what will be more interesting is if I click on this polygon and it takes me to the exact layout. So which is what I can do here, right? So now not only did I run Caliber DRC in batch, I'm also able to open it interactively and do a real-time visualization. And then I'm also able to see that I can identify which layer or which polygon is failing and how I can actually fix it. So just to recap, like what are the different elements that we've seen in our demo today. So we saw how you can set up a storage device, how you can run Caliber DRC in batch, and we also saw that how you can take advantage of the amazing nice TCV technology to open Caliber DRC interactively and do a real-time debugging. I hope this demo was helpful. Yeah, so with that, I want to wrap up today's talk. So essentially, we have seen how Rescale can help customers in the EDA vertical to run the workloads in a fast and seamless fashion. By taking advantage of the agility of cloud, you can really reduce cycle and reduce the time to market. Now, what you've also seen is like the advantage of using a turnkey solution like Rescale versus do it yourself. Because do it yourself is essentially complex, but a platform like Rescale helps to automate, and all you need to do is click a few buttons. And the last piece that I want to focus is Rescale has a best end-to-end turnkey solution. So if you have questions about running EDA workloads on the cloud, or how to take advantage of this amazing technology to help solve your problems, please come talk to us. With that, I want to thank you for joining today. I hope this was helpful, and we really look forward to connecting with you. Thank you.